Ah, okay, right, hi, hi, hi. Okay, let's see question 2.2. Example 2.2, problem. So you read the problem from A to E.
A train moves slowly along a straight portion of a track according to the graph of position versus time in figure 2.7a. Find A, the average velocity for the total trip, B, the average velocity during the first 4 seconds of motion, C, the average velocity of the average velocity during the next 4 seconds of motion, D, the instantaneous velocity at t equal 2 seconds, and E, the instantaneous velocity at t equal 9 seconds.
Okay, right. So we are going through one by one. See what they ask. Can you remember the definition or the formula? Right? Okay. First
Mm-hmm.
one. A. The average velocity for the total trip. Total trip means what, Is from O to C. O to C. That is the total trip. Huh? Okay. So we just concentrate on this O to C. Okay. What is the average velocity? Okay. Average velocity is the delta x over delta t. So at C here, what is the delta x? At C here, what is the delta x? Can you tell me?
10,
O to C. 10, correct. What is the delta t?
12.
12, correct. So what is the average velocity?
Uh,
Use your calculator.
Velocity is x over time, right? Or time 1.2.
Okay. Average velocity is the delta x is 10. Delta x is 10. How to get 10? 10 minus 0. 10 minus
0.
0. 10. Then the delta t is 12. How to get 12? 12
12
minus
minus 0.
0. So what's the answer? Is it 8.33?
0.83. Yeah.
Correct. Okay. So the next part. Average velocity during the first 4 seconds of the motion. First 4 seconds of the motion means from where to where? You read the graph A here. This graph here.
Mm-hmm.
From where to where?
First 4
First
seconds
4
of the
seconds.
motion from O to A.
Yes, correct. O to A. So what is the change in time? What is the change in displacement?
The equation for displacement is where 4 minus 0
Correct. Over.
over 4 minus 0.
Correct. So how much is it?
1.
Correct. 1 meter per second. Okay. So we are going to look at the second part. Average velocity during the next 4 seconds. Next 4. Not the first 4, but the next 4. Next 4 is referring to where? Next 4 is referring to 4.
4 to
You
8.
add another 4. It is here.
8.
Okay. Now for this part of the journey, what is the delta x over delta t? Because you want to find the average velocity.
Delta x will be 4 over
4 minus
8.
4 minus 8. No,
Eh, eh,
the
4
delta.
minus 4 minus 4.
Correct. 4 minus 4. Correct. Then divide by.
Divided by 4 minus 8.
8 minus 4.
Oh, 8 minus 4, sorry.
8 minus 4. So what is it?
0.
0, correct, it's 0. So then you look at the shape of the graph. The shape here is a straight line. The shape here is a horizontal line. So can you
Okay.
what conclusion can you make? This is the straight line. This one produce a straight line. This one horizontal line. Straight line means what? Horizontal line means what?
Straight line.
This one is a straight line with a certain
Mm-hmm.
slope. It means that the velocity is
1.
constant one. Then this one is a horizontal line. Horizontal line means the velocity is
0.
0. Okay, right. So this is what you need to know. Then the third part, average velocity during the, oh, this is it. Okay. D, instantaneous velocity at t equals to 2. T equals to 2. I show you where is the t equals to 2. Now this is the point. This is t equals to 2 here.
Mm-hmm.
This is the point. This point here. Okay, can you see that point? That
Yep.
point is where t equals to 2. You want to find the instantaneous velocity at that point. That means you want to find the gradient of tangent at that point. Can you find the gradient of tangent at that point?
Uh,
Which is the point? This is the point here. T equals to 2, this point. Right? This is the point.
y
How
over
to make
t.
a mark there? This one. I make a cross there. This point. Oh, too far away. Off. Okay, so what is the instantaneous velocity at that point there? The gradient of tangent at that point. Because this is a straight
Mm,
line. So the gradient of tangent at that point is the same of the gradient is the same as the gradient of tangent of the whole line from O to A because it's a straight line.
uh-huh.
So how much is that?
Uh, mm,
This time my mark is correct. What is the gradient of tangent at that point?
1.
Correct, is 1. It's the same as the first part. It's the same as the earlier part B here. So how we get 1? Right? How we get 1? Yes. The slope at t equals to 2 is also 1 because it shares the same straight line as OA. It shares the same straight line as OA. Last part, the instantaneous velocity at t equals to 9. Where is t equals to 9? So I'm going to mark the
t
point.
equals to 9 will be in between, no?
This is the point t equals to 9.
Mm.
This is the point t equals to 9. So can you find the gradient of tangent at this point? They have drawn the tangent for you. The tangent is the green line. They've drawn the green line. So
Yeah.
you just find the vertical divided by the horizontal of this dotted green line then. That is the tangent
Vertical.
at the point t equals to 9. This is the point. So can you find the gradient at this point? They have already drawn the gradient of tangent for you. It is the dotted line, green dotted line. How much is
Yeah.
the vertical distance there?
9. Distance
Four. This is
point
4.
some.
A bit higher. It's 4.5, right? 4.5. Then how much is the
Okay.
horizontal distance
2.5. 3.
from 3 until 9 here? Can you calculate?
4.5. I don't think this is
How
right.
much?
0.75. I don't think this is
Correct, 0.75 meter per
right.
second. Okay, then oh, there's something that you need to take note. Is it very noisy outside? Can you hear me?
It's okay. It's okay.
Huh? Can.
It's okay. It's okay.
Okay.
Yeah.
Right.
Okay.
Right. So the where are we now? Okay. Now, first of all, you note that the first part of the journey here from O to A, it is a straight line. Straight line means you travel with constant velocity. Then the next part of the journey from A to B is a horizontal line. Horizontal line means not moving, stop, not moving. Then from B to C is a curve. Okay, it's a curve. So this part you are moving but not with constant velocity because it's not a straight line, it's not constant velocity. Either the velocity is increasing or the velocity is decreasing. Okay, now?
Mhm.
Okay, the next question is, would a vertical line in a graph of position versus time make sense? Will a vertical line make sense? They say it means let's say there's a vertical line like this from A straight away you go here like that. Oh, is it possible to have a straight line like that? The graph doesn't follow the from A to B. It come from A then go straight up vertically. Is that possible?
No.
No. Answer is no. Why? Because from let's say the t equals to 4, you are at the position 4. Then the same t equals to 4, you're at position 10. That means in no time you fly from 4 to 10, which is not possible, right? You cannot,
Okay.
at least you must take some time to move from 4 to 10. Okay, you must take some time to move from 4 to 10.
4 to 10.
If this is the case like that, then is if this is the case, then it will make sense, right? Because if it's like that, at least you need some time lah. 4 seconds, then you move to another position. But if it is vertical, that means no time, but you move to another new position, which is not possible, right? Okay, you read this 2.7, figure 2.7b, this one, exercise
Figure
2.2.
2.7b graphs make another run of the train. Find A, the average velocity from O to C, B, the average velocity from O to A, and the instantaneous velocity at any given point between O and A. C, the approximate instantaneous velocity at t equals 6. And D, the average velocity of on the open interval from
Okay,
eh,
so what they want
velocity
us to
from
find.
okay.
Okay, let's say hide all this first. Okay, now they are referring to this graph B. Okay, A, find the average velocity from O to C. O to C. O to C is a horizontal line. Average velocity from O to C, what is the delta x? From O,
0,
0, correct. What is the
12,
delta t? From O to
12.
C. O to C is 12. O to C, this is 12 seconds. So it's 12.
Ah,
Delta X is 0, delta T is 12. So finally the answer is 0. Correct.
yeah.
Okay, next part. The average velocity from O to A and the instantaneous velocity at any given point between O and A. So we are referring to this part of the graph, O to A. Can you tell me what is the average velocity?
0.5.
Correct, 0.5. Then at any other point along the curve here. Okay, what is the gradient at any other point along the curve here, along the straight line here? Will it be the same because it's the same straight line?
Yes.
Yes, because anywhere along any point along this line OA, they still share the same gradient as OA. So it's the same. So it's still 0.5, correct. Next part. The approximate instantaneous velocity at t equals to 6. T equals to 6 is where? Here, this red point here. Can you see a red point here? Right.
Mm-hmm.
So I have drawn the tangent to this red point here. So can you calculate the instantaneous velocity at this point, t equals to 6?
Two.
Okay, correct. So 4 divided by 2 is 2, correct. Okay, correct. Then next part. Find the average velocity on the open interval from B to C. This time they don't start from A anymore. This time they start from B, then end up at C. So can you tell me what is the delta X over delta T from B to C? The interval, that time interval.
Um, B to C will be
What's the delta
10.
X?
10.
Uh, Not really wrong, but the direction is wrong. You have to use the final position minus the initial position. What's the final position? The final
12.
position, huh? The
12.
final position is 0 here. The final position is 0. The initial position
Oh, sorry.
is here. This one,
So
initial.
0 minus 10.
Correct. 0 minus 10. So
What's up?
what is divide by how
Yeah,
many?
okay.
Divide by how many?
12 minus 8.
Correct, 12 minus 8, correct. So this is the answer here. Negative 2.5. Negative means what? Can you tell me what negative means here?
Going
Moving
down,
in.
no?
In this case, it's moving to the
To the right.
left. Right
Eh?
is positive, left.
Oh, yeah, left side. Sorry.
Okay, next, the last part. The instantaneous velocity at t equals to 9. Where is 9? Oh, easy lah, because it's along the same straight line. So what is the instantaneous velocity at the point 9 here? Let me make a mark.
0 minus 8 over 12 minus 9. Negative 2 point.
It's the same straight line. This point here is on the same straight line as,
Why I put 6? No wonder, sorry, sorry.
it's the same, along the same straight line. The number, the gradient should be the same.
Negative 2.
It is negative 2.5 because along the same straight line, all the points here,
Okay.
they have the same slope,
Oh, okay, okay,
same
okay.
gradient. So you should be negative 2.5 also, right?
Okay, okay.
Okay. So next lesson we are going to do